Okay. An isomer has the same molecular structure, but there are different kinds of isomers. So if an isomer has the same connectivity, then we're going to call it a stereoisomer. If it doesn't have the same connectivity, we're going to call it a constitutional isomer or a structural isomer. And the key there is that the constitution is very structured, so those are the same thing. So taking on from stereoisomer, if you have to break a bond to get there, then we're going to call you a configurational isomer. And that means you probably had a double bond or some kind of stereocenter. But if you didn't have to break a bond, then you're called a conformational isomer. And this means you can rotate around a single bond. Now, going on from conformational isomers, if you are a non-superimposable mirror image, then you are called a enantiomer. And if you are not a non-superimposable mirror image, then you're called a diastereomer. A note that diastereomers are cis or trans, cis having Z same side, trans having E, and then diastereomers are kind of defined by having at least one, but not all different stereocenters. And then when it comes to enantiomers, there's three things we want to remember. One is that enantiomers have the same magnitude, but different, it's actually opposite sign. We also want to remember that enantiomers are half plus 1/2, and the other half is minus 1/2, so because they're opposite signs, and so their specific rotation ends up being 0. They have 0 optical activity. And the last one we want to remember is that S and R are enantiomers of each other. D and L are enantiomers of each other. All right, that's it for isomer.